So as we move a little bit further into algebra, though, we have rational expressions that take on this look. So we want to simplify this rational expression. Now, the numerator, there really isn't anything we can do because this is basically degree one stuff. The only thing with degree one stuff is if there's a common factor between these two terms, we could pull out a common factor, but there's not. But notice how the denominator, though, kind of models what we call a difference of squares. A squared minus b squared. It will factor into the form of a minus b, a plus b. So remember, 7 times 7 is 49. So what I can pick up on then is, in working this problem out, and I'll do that over here, scratch area, but you could be just writing the answer in. But notice how a squared, notice that 7p squared is the same thing as 49p squared because 7p times 7p is 49p squared. Notice that q raised to the power 2 is q squared. Not a g, but a q. Sorry about that. Go the other direction. So notice how the 7p is actually the a, if you will, and the q is actually the b, if you will. So we have this a and this b. So what this tells me then, I can use this formula, a minus b times a plus b, and it will turn into the factorization of 1. So on the numerator, I'm going to just leave the 7p minus the q on the top. But in the denominator, that's a difference of squares, so it's going to factor into 7p minus q and 7p plus q. So when we look now, notice how the numerator and denominator have the same 7p minus q factors, so I'm allowed to divide it out or cancel out. Remember, when it cancels out, it turns into a 1. So that means that since there's nothing left in the numerator, we have to use the 1 because there's nothing else left. So the 1 would be our numerator, and our denominator would be the factor 7p plus q. And that's as far as we could take that. So that rational expression would reduce down to 1 over 7p plus q.